Welcome back to Masters and Makers. I am happy to be joined today by Angus Leung, founder of Westminster Lab. Angus, good evening there.
Good evening. Yeah. Good morning on your side.
Thank you. How did you come to start Westminster Lab?
Um, it was a long story. I mean, I started my kind of music, and I started enjoying music when I was like 12 or 13, when I first got my MD Walkman. And then I started experiencing with different earphones and earbuds, and I kind of fascinated by the quality that you can get from different earbuds and the way that you can enjoy different musics from them. So my family, kind of like my father's brother, actually was kind of like an audiophile. He had a full Macintosh with Bowers and Wilkins speakers back then, so he was kind of like my mentor back in the days, and he got me into this rabbit hole in a sense.
Well, how did you come into the business of manufacturing and designing products? Bring me up to the present day, Westminster Lab. How did Westminster Lab itself come into being?
Well, it was still in the early days when I was still studying in my high school. I had the opportunity to work in audio repair store,
Hmm.
which customers actually brought their old Corels or Mark Levinson for repairs and upgrades and restoration. So it kind of started like that when I get to know the stories, or actually what was the backbone of these incredible machines. And then I started creating my own products in a sense for my friends. And then it started to grow a bit. Every summer holiday I was working there, earning a bit of money, testing out new ideas. And then after university, well, after I graduated in the UK, and then I started thinking maybe this can become a serious hobby. So,
Hmm.
and I started Westminster Lab back then in the UK.
Tell me about the organization of Westminster Lab. How many people do you have working with you?
Well, including me, we only have three people
Hmm.
at the moment. So we are a small company, and we intend to be a small company too.
And out of those three, does somebody or one or more of those people among those three do the actual designing of the components? So who actually designs the components?
One of my partner actually do the electronics schematics design, I would
Hmm.
say.
Hmm.
But we all work together in a sense because we all listen to it and we comment and we gave new ideas and new directions of what we should do. Personally, I'm responsible for the mechanical design and industrial design
Hmm.
of the units because of my design background.
So I understand. So that other one of the three does the actual schematic design. You do the industrial and ergonomic design. Who
Yeah.
does the actual assembly of the components? Where are the components being physically put together?
It's also in Hong Kong. So we had a very small workshop in the area in Hong Kong, and we do everything there, basically all the assembly, all the testing, and research and development. So even myself actually worked on these products.
And the one of the three of you that does the schematic design, is that also the person that did the I bias circuit for the REI amplifier?
Yes, he was. Well, we used the iBias in the Ray, but it's nothing new in a sense because fluctuating bias and actually been in the market for quite a long time. Like
Hmm.
Crow, I mean, used to use it in their KSA, I think, line.
I was going to ask you about that. So, how does your I bias circuit differ from the Krell I bias circuit, which varied the bias based on the current at the output stage?
It's very similar actually, but we had a very much higher in initial bias.
Hmm.
So the current actual bias actually doesn't vary too much in a sense
Hmm.
in our application. Um,
Tell me about Altria alloy. How did that come into being, and what is the metallurgical composition of your alloy?
it's basically majority copper. So
Mhm.
it's a 96%, 95, 96% copper. And we add a little bit of silver and gold and
Hmm.
some other expensive material in there. But to be honest, it's nothing special, I would say. I mean, because a lot of other cable companies use alloys. I mean, like
Mhm.
Siltec or Crystal Cables. or even and stealth. So, but one of the unique points which I want to point out actually for our cables is the unique structures like the rarities.
Why does Ultra alloy sound better to you than copper or silver plated copper? What do you hear different about what your alloy is doing sonically?
Well, interestingly, if you measure the pure conductance, I would say for pure copper on alloy, actually the pure copper may have actually be a little bit better in
Hmm.
terms of pure conductance.
Hmm.
But we think in for some reason or some kind of unknown reason actually, we found out the transition between different frequencies within the musical band actually sounds much smoother with our alloy. So we kind of go for that.
When you say transition, are you talking about the linearity of the velocity of propagation?
Yeah, I mean, and more of like the texture of things, when you hear something, for example, if you hear a piano and it transits from the high notes to the low notes,
Mhm.
you hear a more linear transition in terms of texture and propagation, and we kind of like that. I mean, it's very difficult to explain in terms of scientific measurements. I mean,
Mhm.
we are also kind of quite shocked by it because in terms of pure resistance or conductivities of the conductor, the pure copper will be actually better choice.
Where does your copper come from? Where do you source the physical copper from?
We have a supply actually in the UK to extrude the copper for us.
Mhm. And why do you prefer solid core conductors over stranded?
Um, there's a skin effect. I mean, there are quite a lot of materials and papers about the skin effect. We
Mhm.
think it actually contributes a lot, and because if you have braided conductor, is that what you call it? When you have a few coppers conductors which have joined together and to become one conductor,
Mhm.
it kind of disturb the skin effect a little bit, and we found out I mean, for ourselves, we prefer a more unified sound of a solid core. It's more focused in a sense for us.
Why do you make your shields out of carbon fiber?
Um, because we think from our experiments, we tested quite a few, even for copper braided shielding. We think carbon fiber has a sort of property of course, it's a very good shielding materials, but it doesn't induce the eddy current effect if you have a copper braided shielding for the cables. So we that's why we use it.
And what difference do you hear between the eddy effects of the copper braiding um, versus the carbon fiber shielding? Are you able to articulate the difference in sound you hear between those two types of shields?
Yes, I mean, we tested, for example, like if we use the if you use the copper shielding, it sounds a little bit, the shielding properties is very good. I mean, we have a much quieter background, of course, but somehow we hear a little bit of fuzziness, when the subject is when you hear an instrument, there is kind of like a haze around it. It's not that sharp in terms of the imagery. But with carbon fiber, we may have a little bit less in terms of quietness. But because of the focus is much sharper, we think the darkness of the system has been improved.
I thought the use of carbon fiber is really pretty ingenious. What is the nature of that shield? Does the signal carrying conductor go through a tube which is completely fabricated of carbon fiber? So how do I envision the carbon fiber shielding? Is it a tube that the conductors go through and the entire tube is made out of carbon fiber, or is it carbon fiber pieces along the way? What is the nature or coverage of the carbon fiber shield of the conductors?
The cover fiber actually covers pretty much 100%
Mhm.
of the whole cables on the exterior. So that's why you can see it's colored like black.
And I know Westminster Labs started with cables. How did you make the leap to electronics, amplifiers, and preamplifiers?
Back in the days when we are still doing research and development of our cables, we actually been using our own electronics. So alongside when we developed the cables, we actually use our own amplifiers and preamplifiers for the testing. And we found out there are two reasons basically. When we first joined, quite a lot of audio show, and quite a few of them, and we only display cables. A lot of people will think, cables are very easy to make, so it's not very technical. I mean, lots of people can draw up the cables, and it sounds pretty good. So we want to prove ourselves to be, very technical, and we are capable of doing something quite special. And quite a lot of people actually think our electronics are sounding pretty good. So we decided that we want to explore a bit more in this kind of field.
What is the sonic advantage of using pieces of carbon fiber in the Quest preamplifier?
It's also a properties of the shielding, basically. Is because for example, like the preamplifier, the signals are very small, so we have to protect it as much as we can. Of course, in the Quest, we had a very short signal path. I mean, less than 15 to 16 centimeters, so around 5, 6 inches, 7 inches maybe. So although it's a very short path, but the signal is very small. We're talking about perhaps, for example, couple of hundreds of millivolts, and then and with carbon fiber shielding, we actually achieve quite an improvement in terms of sonic and also measurable performance.
In the Quest preamp, you devised what you call a hybrid grounding system, which allows the user to switch between two different grounding modes. What is each of those grounding modes?
The first one is a completely isolated left and right channel in terms of grounding. So it's a complete dual mono configuration.
Hmm.
So the ground actually doesn't cross. The second mode is a cross hybrid grounding. So the left and right actually crosses at one point. We found out for some systems, depends on the DAC and also depends on the power amplifier. It may need the crossing in between in order to reduce the noise.
So it's not a matter of offering the user two different sounds as much as affording maximum compatibility with whatever their existing grounding and electrical infrastructure may be.
Yes, because we found out quite a lot of users actually use ground boxes, and they experience, experiments with different grounding methods, individually or star grounding, or actually doesn't do any groundings at all. So we want to maximize the compatibility of our preamplifier. So of course we would encourage them to use our power amplifiers, but if the customers choose not to use so, because we do have actually quite a few of our customers use an active speakers with our Quest. So this offers a greater compatibility, but it sounds a little bit different too. So it's a bit of both.
Is the dual grounding mode option designed to obviate the need for your clients to use third-party grounding boxes?
Yes,
Or
in
not
a sense.
necessarily?
Yes, actually, because the grounding method that we use to design in our electronics are quite not what I would say quite different, but I would say it's quite sensitive. So if a customer's experience with experiments with the grounding methods, in terms of using external grounding box, it may actually mess it up,
Hmm.
mess up our own grounding sequences, I would say. But of course, I mean, if the customers is willing to experiment, with that, it's fine because it won't do any harm to our products.
In a friend's system where we auditioned the REI amplifier twice, I actually heard to my ears on his speakers in that system in that room, I heard your amplifier sounding better to me than at least one and possibly two traditional Class A, big, heavy, high heat amplifiers. What
Mhm.
is your theoretical explanation for why your sliding bias circuit might actually sound better in some cases than a traditional full bore Class A?
I would say for most of the music that you listen to, it's really difficult to be out of our class A range. So that's why we think a sliding bias would be a very good option in terms of power supply design, because when you have a lower bias, when you're not needed, then you will have a much better headroom in terms of power supply. So rather than, let's say, 100%, then you have 150%, with that actually brings a better measurable performance in terms of power delivery and speed. And and um, and also, I would like to talk about the reason why we have such a small package. Of course, I wrote quite a long story in WordPress forum explaining it, but I think I have a much simpler explanation now, because it's very simple. Because when we look at our amplifiers, we designed it deliberately not to go linear output down to 1 ohm. So we have linear from the double down from 8 ohm to 2 ohms rather than 1. So basically, we have half of the transistors if you compare to another similar power amplifier at 8 ohms, because we need half of the current. So we have half transistors, that's already half of the power outputs. And then when you look at our amplifiers, we actually have a much lower rail voltage compared to other amplifiers, let's say Krell or Acuphase, because we think for amplifiers, for most of the customers, they don't really listen to such a loud volume. So we don't need the actual peak-to-peak voltage output that we need in terms of the rail voltage. And if the customers actually listen to the music quite loud in the loud music room, the customers can actually bridge the rail externally, so doubling the voltage. So we tackle the issue very, I would say, cleverly. That's why we can put Class A performance inside a small package.
But even by reducing the typical number of transistors by half, the REI box weighs way less than half and generates way less than half the heat of a
Yep.
traditional Class A. So is it mainly that you're foreclosing the possibility of doubling and doubling and doubling down to 1 ohm or even less than 1 ohm? So you're not worrying about designing to solve that particular equation. And is it also that you're mostly in relatively high bias, and that the peak for a higher bias occurs in the natural course of the musical signal relatively rarely?
Yes, that's right. And when we reduce the transistor by half, we have around half of the heat output. And when we reduce the rail voltage by half, we actually reduce the heat more than half. So we have like a quarter of what an equivalent amplifier will have, 100 volt 8 ohm amplifier will have. So it's what we think is a clever solution. So we didn't cheat physics, of course, but we think we set the amplifiers up quite cleverly, because we think quite most of the speakers nowadays didn't go really down below 2 ohms, but rarely. And for speakers which does, like the Apogees, the ribbon speakers, they are resistive load. So they doesn't have an impedance curve which goes up and down, up and down. Is a regular resistive load. So basically, you don't really need to double down for such a load.
I heard it myself. I think the amplifier sounds great, at least in my friend's system in that room with my ears. You're doing something right. There's just no doubt about it.
Thank you very much.
Why does using different power chords change the sound of the Quest and the REI?
Well, that is a very difficult question to answer. Um, I mean, in terms of listening tests, of course, we found quite a lot of differences between them. What we think is the matter of the sound difference is, of course, is the impedance of the power cord, first of all, and also the ground that involved in the power cord, because what we always think the ground is an infinite black hole, when we think, oh, everything goes down to the ground and everything will be sucked out, all the noise, blah, 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 it will be gone. But unfortunately, we don't think that's the case because ground is still an electronic connection. And this is an essential lead connection because when you have a load, if you have a limit or bottleneck in the ground, it's also a bottleneck and a limit within the whole circuit system. So what we think grounding is the return of the signal or return of power delivery or return of anything is quite a key. And we think the power cord actually is one of the key components. That's why it makes the sound quite a bit different.
And grounding is not a monolithic thing. An audiophile can bring an electrician to his or her system and measure in that particular situation the exact number of ohms, the resistance to ground. Different systems and different electrical infrastructures and grounding arrangements measure different resistance to ground. So
Yeah.
people's grounding systems truly are different.
Yes, I mean when we talk about when you talk about the real earthing ground, of course it's very important. But for what the power cables does is the electronic ground, because which is a virtual ground, is the ground created from the secondary winding of the transformer, which is heavily related to the power cords. Because the signal ground within the amplifiers or preamplifier is sort of isolated from the earthing ground, the ground of the earth, in a sense.
Tell me about your system building philosophy. If a novice audiophile comes to you and says, Angus, I want to put a system together. What should I buy first? How do you advise somebody to go about putting a first basic system together? Should somebody start with the speakers and match electronics in the amplifier to the speakers, or start with the person's favorite sounding amplifier and then find the speakers that are appropriate for that? What is your kind of system building philosophy?
For me, I am believer in terms of room coupling and also a preference of personal taste. You know, it depends heavily on what kind of music the customer is listening to. You know, I always think if the customer wants to listen to one sort of music, or maybe he has a collection of one or two maybe particular genre, they can actually tailor the needs of the speakers that they want to listen to. For example, like if you listen to a lot of jazz, a horn system may be a brilliant idea, you know. But if you listen to a lot of, I don't know, or maybe hip hop music, then a horn system may not be something for you, you know. And also the room is actually very important in terms of speaker choice. If you have a room which is like 100 meters square or 200 meters square, it's very impossible for a dynamic speakers to push out such a volume in terms of fill the room. But you have such an efficient horn system or maybe a ribbon system, then it will be much easier. So I think it's, first of all, for me, I mean, I would advise think about what sort of music you would like to listen to, what sort of volume you would like to listen to, and what sort of music room that you have, and then you find the best speakers for that first, and then all the electronics will fall into place.
What speakers do you use in your at Westminster for voicing amplifiers and listening to amplifiers and evaluating components?
We have three branded speakers. We have two listening facilities. One is at the R&D manufacturing place, which is a smaller system, and we have a full range horn, Foster's horn, and we have a pan audio medium size floor standing speakers, pan audio from Denmark, I think it was from Sweden, and we also have our own DIY acumen drivers bookshelf speakers. And in our bigger listening room, we have the Vivid Audio G1. And we also we used to have Apple G Divas, but now we pack it in the storage because we need new ribbons for it.
How are you planning to get the new ribbons sourced?
We
Send them to Graz in Australia, or?
No, actually, there are quite a lot of people making them. I mean, we had a supply in Germany actually manufacture the tweeter, the mid-range, and also the bass drivers ribbons for it.
And there's
we plan to order.
And there's an Apogee restorer in the UK, I understand.
Yes, but we are in Hong Kong, so we are in Hong Kong at the moment. Because I moved the company back when I graduated, and I need to be with my family. So So we decide maybe we can do it ourselves, and then we will see what we can do with the Apogee. It's a great sounding speakers.
What is going on in the research and development department at Westminster? What is the next new product we should expect from you?
Recently, we have been working quite hard on developing phono technology.
Hmm?
So we're very lost in the vinyl world. We are so deep into it. So the past 1.5 years, we're working on it. So we brought out the new MC phono module for the Quest, and also we work with DS Audio, and now we have a certified DS Audio module for
Oh,
DS Audio cartridge. Yes,
huh?
we are the third international manufacturer to be certified by DS Audio to
Very
produce
interesting.
equalizers. Yeah, we're very excited about it, and we think they're doing something amazing, something new.
And do you have a DS
And
Audio, do you have a DS Audio optical cartridge on one of the tone arms on your turntables in your shop?
yeah,
Mhm.
yeah. We have the W3, so we were one of the first manufacturers to get our hands with the first generation optical cartridge, and it's pretty good actually.
And
And
this
sorry,
and
please
this will
go
be
ahead.
a module that can just plug into the Quest.
Yes, yeah,
So
and
so
actually, sorry, please
the
go ahead.
regular phono stage, the traditional phono stage, is also a separate module. So there are no external outboard boxes. It's all modules that plug into the Quest.
Yes, the Quest has two built-in optional bays. So we currently have an RCA input module. So it converts the RCA input into balanced signal for our Quest. And we have the MC and MM phono module in RCA and XL inputs. And we now have the DS Audio input card with RCA connections.
Angus, what do you do for fun outside of audio?
Well, I have quite a few hobbies, I would say. I mean, I like to do things with my hands. So I do a bit of repair with my cars, and I don't have much free time,
I'm sure.
unfortunately.
I'm sure.
But I listen to quite a lot of music actually.
Mhm.
You know, I for us, I think we are one of the few companies. I mean, especially in this kind of scale, which is very serious about listening tests.
Mhm.
And I think we are one of the few, especially small companies, to have such a privilege to have such a great listening room with quite good of a wider range of speakers, and I think we're quite proud of it actually to have such a testing facilities.
It's very important.
Yes, it is.
Well, thank you so much for joining me tonight, Angus. I really appreciate it. Great to speak with you.
You're welcome. Thank you.
Have a good night there.